And welcome to another episode on the TSA Ed Supply podcast. And we're talking today about part 2 of static pressure that we posted several weeks ago. And I want to go over just a little bit about what is static pressure. And if we have any background noise, I do apologize for that. But I want to talk about part 2, what is static pressure. And then I also want to remind you, go to www.tsaedsupply.com. That's TSAEDSSUPPLY.com. And on that website, we'll have a list of training classes, when and where the next classes will be. There'll be some training information on that website. It's a place for manuals. So if you're out in the field working on some ICP equipment and you need an install manual or a service manual, you can get that under the manual tab. You can also get some information that we'll post, some blogs that'll be on there. The podcast will be on there, as well as some helpful things. Like there is a episode 3 that we're going to talk about is why compressors fail. That document will actually be on the website that you could actually print off, keep it in your van if I haven't already given you one, and it's mine are laminated, so if you'd like to have a laminated one, let me know. But you can also go in there if you're working on compressors, and we'll get into that in episode 3. So today I want to finish up what I can on static pressure. What is static pressure in the HVAC system? Well, it's simple. Static pressure is essentially air resistance. It's in an air-forced HVAC system. The ductwork relies on air being pushed through the ducts to circulate warm or cold air, but various factors inhibit that airflow. So the force of the air must be stronger than the resistance. So the resistance would be 90s with no turning vanes, deadheads, duct board, spider boxes, vertical rises, a unit trying to satisfy 2 floors of a house with ductwork going up a chase. All these are going to have resistance. They're going to cause the air to have turbulence inside those. So you have duct board is one of the most notorious for those, where the air is coming along the side and the insulation will cause turbulence. So if you have ductwork that's square and you have insulation on the inside of that ductwork, it's basically the same as duct board. It is the worst high static pressure system you can have in your house. The best one is hard pipe, followed by flex that is stretched out as tight as possible. And we'll go through some of those things hopefully later in this segment. If not, we'll cover it in a ductwork podcast that we'll talk about. I hope to have some of the service techs and service managers on the broadcast as well, so maybe we can do what we can to make sure we get a lot of the topics covered. But it's important not to have any resistance at all. It'd be great if every house was exactly the same cookie cutter mode and these units come off the factory preset. That's not what happens. And a lot of the installers we're seeing will set these units and just assume everything on that unit is perfect because you paid X amount of dollars for it, or you got it at a brand X warehouse, and you just assume, well, it's a good name brand, it's supposed to be done right. There's a lot of things that's supposed to be done right in life, and in this field and industry, when COVID hit, they lost a lot of workers and a lot of employees, and so trying to get good employees to do the job right was hard. So they had to take people that were not usually on the assembly line of a unit and make them on the assembly line of unit. So you have to deal with that there. So you're going to have some tweaks. So I always recommend when you get a brand new unit, check everything. Check the contactor. Check the wires on the contactor. Make sure there's no loose wires of any kind. Make sure all the wiring is pulled up. Make sure none of your wiring is touching copper or intersects copper or intersects any kind of cap tubes. So vibration, that unit's going to vibrate. And a lot of times they'll pull these wires tied across copper. In about 5, 6, 7 years, you're going to have some issues out of that wiring. So double check all that. Don't take anything for granted nowadays. But a HVAC professional, and I don't want to be too critical, but sometimes we can use that term loosely. Just because we do it for a living doesn't make us professional. There are service techs that just learned from what their boss showed them or trained them, and they don't further their education. Things are changing. Like I said in episode 1, the units are not made like they were 5 years ago, much less 10 and 20 years ago. So you really have to understand how things are changing. And the trend is going to more efficiency standards, higher efficiency standards. You're going to see bigger coils. You'll see microchannel coils. Some of the units have already microchannel, and we all know, I'm not going to name the brand, but everybody out there knows what happened when microchannel went into heat pump on some of these units and how there was leaks and pressures and all these things were going on with it because just wasn't tested long enough in field. You could test it in the lab with a 0.02 static pressure and everything be fine. But when you put it in somebody's house who is 0.90 up to 1.23, you're going to have issues. And back in the older days, say 10, 12 years ago, you could set a unit and you're in and out 3 hours on a package unit, and and you didn't think nothing else like it. Well, things are different now. So static pressure is so very critical and so very important. And perhaps one of the most frequently ignored factors in setting up a duct system is the external static pressure, or the ESP. It's the measurement of all the resistance in the duct system that the fan has to work against. So you're going to have filters, you're going to have grills, you're going to have the wet coils from the AC, the heat kits, and the ductwork. All those, because these units don't produce air, they just move air from one end of the house to the next. And the blower motor has to suck air from the house and go through the return grill, through the return filter, come up through the blower hat, the ductwork, go up through the air handler, through the heat kit, or through the wet coil, whichever one it is, and then back out the supply and through the flex, through the boot, and all the way out to your grill, and the process is repeated. So everything it has to come in contact with or pass through causes resistance, and that will determine your static pressure. The goal is to have as minimum static pressure as possible. And to give you some kind of ideas, on a return, you should have a 0.01, 0.02, or 0.3, 0.4, or 0.5. When you start seeing numbers over 0.05, then there's some restrictions there that you need to address. And if I won't say that, I will say it's just about in every situation when you're seeing restriction. You could have a dirty filter, you could have kinks in the flex, you could have fan speed off. So many factors you could have, but and in order to do that, it's the sum of the suction pressure, which is negative, and the discharge pressure, which is positive, created by the equipment blower. It's just like a compressor. When you put your gauges on a compressor, you look at your suction pressure and your discharge pressure to find out what that compressor is doing, to find out what kind of load that compressor is under. But what we don't ever look at is the blower motor, whether it be in a furnace or in an air handler. That's the same kind of pressure a blower motor's under. And a lot of people don't look at that. In an old system, you would have, and I'm sure y'all have heard these terms, where a squirrel cage may be completely full with lint and dirt over the years. Is it as effective? Does it move enough air with like a clean squirrel cage? Of course it won't. And those motors will overheat because they have to have a certain amount of cool air coming across them to even keep the windings in the motor cooled down so your motor don't overheat. And then you ask, well, what happens when a motor overheats? You're going to think it's a bad TXV. It'll show the same signs as a bad TXV, and then you'll go and replace the TXV and never fix the problem. And so many times of these compressors that go out and these blower motors that go out are due from lack of airflow because of static pressure not being set. So let's dive into this just a little bit. Blowers just move air throughout the system, and they're designed to overcome restrictions. So just because you have a blower motor in and you set that blower motor on high doesn't mean it's overcoming the restrictions. So what we want to do is we want to eliminate as much restriction in that ductwork as possible. So the external static pressure is measured using a manometer, which is the same device that you use to check your gas pressure in your furnaces with. Now, a manometer, you need a dual manometer, and you've got to have the tubing and the duct probes. If you do not have the duct probes, you are not doing yourself a favor at all. You'll get the wrong information, the wrong measurement, and basically just wasting time and money. So you want to make sure you have a dual manometer with the duct probes. Now, field piece, I use field piece. I have a Bluetooth set, and I have a regular manual set. But I also seen one that was pretty cool, the Yellow Jacket. It's a little on the pricey side. It's a little bit more compact. Maybe it fits in your tool bag a little better, but you can check into that one as well. The airflow rate, or the CFM, of a motor is directly related to the external static pressure. The higher the external static pressure, the lower the CFM the motor blows. The lower the static pressure, the higher the CFM. High static pressure readings indicate that there is excessive resistance in the system. This may be caused by dirty filters, dirty evaporator coils, closed dampers, restriction from the supply and return grills, or undersized ductwork. If you know the external static pressure, you can determine the CFM, because every unit on the install manual, do not throw them away. ICP puts an install manual inside every piece of equipment. They leave it up to you to read it. And most of the time, if you look at a manual, you're going to find the chart in there. I know ICP does it on every one of their pieces of equipment, and I'm sure other brands do as well if you just take the time to actually look into it. But I'm looking at right here, I just happen to have it on my desk, is a ICP model number, November 92, Mike Sam November. So it's a gas furnace. All right. And in this, on pages 48 and 49 of the install manual, it has static pressure. And at that static pressure, it tells you what model number unit you have. Has the new MSN furnaces from ICP have 18 speeds. So you have certain speeds that produce certain static pressure will produce a certain amount of CFM. For instance, I'm just going to use this as an example. If your unit is defaulted on set number 8, if you have 0.1 static pressure, that number 8 blows 900 CFM on that particular speed tap. But if your static pressure is 1.0, that 900 is reduced down to 385 CFMs. What happens? Well, the homeowner is going to be irate because you're not getting enough CFMs in the house, and you're not going to heat and cool the house. So, not knowing that, you'll set a unit in, and ICP, like any other brand, they'll a lot of times put their blue wire on air handler on pin number 2, and then the white wire or the red wire where the white goes is going to be on pin number 4. The reason ICP does that is number 4 pin has to be set there because that motor turns a certain amount of RPMs and CFMs produced that if you go any lower than that, you're going to cause major issues with your heat kit. Could be wires overheat, could be the heat kit itself overheats, limits tripping, all those things. So you have to have a certain amount of airflow coming across that. So Proper static pressure will allow your system to deliver heated and cooled air optimally, which translate into lower utility bills, less failure of expensive parts, and greater comfort to the homeowner. So high static pressure is the leading cause of compressor failure in X13 motors. I'm going to say that again. High static pressure is the leading cause of compressor failure in X13 motors. Now, every electrical issue with a compressor, most times if you go out there and the windings are burnt or the windings are shorted out, that is most likely caused by an airflow issue. Okay, so all electrical issues are caused by mechanical issues, but not all mechanical issues are caused by electrical issues, or none of them are. So if your compressor had an electrical issue on the internals, you can bet you it was a mechanical failure, and you need to find out what that mechanical failure is, because if not, you're going to be replacing that compressor in a short amount of life or short amount of time. Now, a high static pressure can reduce your cooling efficiency SEER rating by 50%. The high static pressure can reduce your capacity, like we just shown, from 40 to 50%. Well, when you go from 900 to 353, you're more than 50%. So you're going to have a very angry homeowner, and bad word of mouth travels a lot faster than good words. So I want to reiterate, it's a dual manometer, and you need to have the duct probes to go in with your dual manometer. Now, then we're going to go in, well, how do you take these duct probes and how do you put them in? It's a 3/8 drill bit. You'll drill a hole anywhere from, say, 8 to 10 inches off of the air handler or furnace or coil, and you can take a reading there. Now, let's say you're doing an air handler, you can come 8 to 10 inches off the front before a 90 and take a reading, and then you can, after the 90, take another reading. And sometimes you'll add those together to see what that total static pressure is. I've seen it done different ways. When I teach classes, there's charts put out by ICP, and they will take a reading from like right on top of the unit and up around past the 90, and they'll add those two numbers together, and then you'll add your numbers to your return. So we'll get into this here and briefly. So if you're looking at some of the test port locations, you can go above the A coil, and you can go into the heat exchanger if you're in a furnace, and you can go into the blower housing and before and after the return grill. So you want to look at that. You want to look at coming off of a wet coil, any deadheads, turning vanes, all that. Keep all that in mind. That's going to slow down and cause pressure. But I really want to see for myself what's going on if I have I want to go after the return grill and before the unit, and then I want to come off the wet coil, and I want to see what my static pressure is. And you always want to do this in the high setting, which is usually AC mode, and let that thing run 15-20 minutes. Let that coil start to get wet, because we want real life scenarios. So let it run 15 minutes to 20 minutes. Run it down to where it won't satisfy the thermostat. Keep the filter in there from the homeowner and really look at these numbers and see what it's doing, because you got to have real life scenario, because things that will happen if you push it through real life scenario, as compared to when you leave and then the homeowner calls and said, hey, now this thing's having issues. So I've seen it in return to where if you look at where to test that, you have, say, 8 to 10 inches past the 90 in a return, and let's say you get a 0.16. All right, and then you look at where the filter is, and you may get a 0.21. You add those together, that's coming outside the unit, okay? So if I'm testing at the unit, I should have the same as what those two numbers would be, and that would be a 0.37. On the supply, if I go in the ductwork 8 to 10 inches past the original first 90, let's say I get a 0.15. And then I'm going to test it again at my evaporator coil, and let's say I get a 0.27, then that would add up to about 0.42, which would be the same as if I put it right at the top of the furnace before the A coil. Then you're going to take those two numbers, 0.37, and you're going to add that to that 0.42, and that would get you a 0.79 inches of water column, and that would be like a real-life working scenario. So now you look at, okay, I have almost a 0.80 static pressure. Well, if you then take your install manual and you look at your chart, 0.80 on my static pressure, and I come down and I'm going to look at my blower motor and see what pin. So if I'm in AC, I'm going to know automatically with ICP that that's the blue wire on the X13 motor. So let's say that blue wire is on speed tap 2. Then I run over and I find out what speed tap 2 all the way over to 0.80 CFM or 80 static pressure is. And if that doesn't add up to what I need to have, then you are starving that system. So for instance, I got called out on a service call, and I was at a brand new house, and the unit was it was a 2-ton system, and it was a 2-story house. So upstairs was 2-ton, and the homeowner was complaining that in the summertime they said it worked fine, but the wintertime it just would not heat the house at all. And they were very, very angry. So the first thing we do is we go in, and I asked the tech, I said, have you checked your static pressure? Let's just check static pressure. That gives us somewhere to start. So we looked at it in AC mode, and we had to speed it up to put it in pin from 2 to 5, and that delivered with a static pressure reading at the slot number 5, gave us 850 CFMs. Well, it's a 2-ton system, so it's going to put out from the factory 800 CFM. We know we have to have at least that because it's what the house was sized for. So 830 was a good number for the supply. Then we took a reading in heat. We turned the air off, let the heat run about 10 minutes, and we tested it, and it was 445 CFMs. And not only that, but they had a 5 kW heat kit in it. So the unit was only producing 64-degree air on a brand new unit. And you can imagine if you was the homeowner how mad you would be if your unit was only putting out 64-degree air. So what was the fix? Well, the fix was the house was mainly flexed. None of the flex was pulled tight. It was drooping, it was sagging, it was turned, it was kinked. They didn't have any of those flex bends to keep it formed and flexed out. And so at that point, there was nothing else you could do besides increasing the supply duct. They did want to do that. So the quick option was to take that 14-inch flex off and put 16-inch flex and pull it tight and start from there. And you could probably dial it in a little better so the unit could at least breathe. Was that overdone and uncalled for? Absolutely. Because if you would have hard piped the job and tested your static pressure, you would have known immediately on startup if you were in the right or not. So let's hit the pause button right there. All right. And I'm going to kind of give you this little nugget. When you go to size the house, I hear this all the time. When I got in the business in 1994, we sized the ductwork at 1.0 friction per 1,000 feet. All right, so you size your duct at 1.0. That's not static pressure. That's friction per 1,000 foot. So people look at that and go, okay, well, I designed my unit at 0.08 and thinking that's static pressure. That's not static pressure. That's how much friction that you're going to have at 1,000 feet. So it relates to your static pressure, but just because you set your ductwork sizing at 0.08 or 0.80 doesn't mean your unit is sized for 8 on your static pressure, and you think, okay, well, my unit still should be good. Not necessarily. So you really need to look at that and go, okay, well, now ASHRAE has a list out where 14-inch hard pipe will carry 1,000 CFM, but 14-inch flex only carries 700 CFM. So now you look at, okay, well, if I've got a 2-ton unit and I've got two 14-inch flex on it, which is what this guy did, he's only really getting 700 CFMs through that ductwork. But on the AC side, he was pushing 830. So what does that mean? It's going to have a lot of suction coming through there. The velocity was a lot higher because it's trying everything it can to, as you make the size smaller, you're going to have you'll hear it. In other words, there'll be a lot of velocity, so you're going to hear the noise of the unit running. So the homeowner won't be happy with hearing the unit run and the air blowing sometimes, especially when they're trying to sleep at night. So they recommend upsizing the bedroom ductwork, and also when you set a unit, don't set it where the bedrooms are located at. So because at night when everything's out, they're going to hear the unit running, they're going to hear the air coming through the ductwork. It can make for an unpleasant experience. But in doing these things, you want to be able to test your duct probe on the supply and on the return and add those numbers together. Do not subtract them. So if the return is a negative, like say a negative 0.37, make it like it's a positive and add them together. And that's going to give you a understanding of what kind of restrictions. So then you're going to know, all right, if my return should be 0.02 or 0.01, you're good. So that's not the problem. Problem's going to be in your supply. But if your return is 0.08, you've got some restriction there. So you could have a dirty coil, you could have flex bent up. So you could actually go in to where you have a bigger flex and drop that resistance to 0.01. And sometimes that's a lifesaver on a motor and a compressor. Or maybe you go in and you hear a compressor going, rattling real loud. That's a sign it's under stress. I've heard ICP units just out of the clear blue just start real loud rattling, and then they quieten down. Static pressure. The CFMs are not set right. Could have, you got some people that have those 4-inch wide filters, and they change them once every 45 days to 3 months, 90 days. Some of them say, well, it's 90 days. You can imagine what that unit's going through. So if the static pressure is not set right, they're doing more damage thinking they're purifying their air more than what they're really doing. So all these things need to be taken in consideration. So one thing I would highly recommend is always, I don't care what you're doing, if you're going to set your ductwork at 0.80 friction or 0.10 friction, still do a static pressure test. Still make sure your static pressure is never over 0.05 if possible. That's your sweet spot. It's 0.05. The unit will tell you what it's tested at on the data plate. It'll tell you if it's 0.2 or 0.5 or whatever it is, and then you'll hear people say, well, I've got this high static system. And we have a unit here called a PHJ. It's for high static applications. It don't come shipped that way, and that doesn't mean it's going to survive. And it doesn't mean that the CFMs are going to be okay, because it won't be. It just simply means I can move up to high static if I'm in that situation. But if I've got a 3, and I've proven this here in our shop, I took a 2.5 ton system and didn't set the static pressure on it, and a 2.5 ton should blow out 1,000 CFMs. I was putting out 420 CFMs. So then why would I need a 2.5 ton if I'm only going to get 1 ton of air out of it? You got to ask yourself those things. So this is why static pressure is so very important, is always make sure you know, because the static pressure won't lie. Also, when you're running flex, make sure your flex is pulled tight, path of least resistance. Don't put a lot of 90s and bends and turns. Really think about the install. Make sure you've planned your install out. Use hard pipe when you can. Yes, it's labor intensive, but you're going to be a lot better off with it, because you look at hard pipe, takes a little bit more labor in the long run, but you have such better static pressure results when you use hard pipe. Not everybody's going to do that, because you're always going to have that guy that says, well, I've been doing this for 20 years, and I'm going to need I've been doing this 20 years and I know what I'm doing and I've never had a problem. Well, just because the homeowner didn't call you and gripe about it to you doesn't mean you didn't have a problem. Homeowner could have easily called another company or could have easily said, hey, this thing's never worked right since it's put in. I went on a job and the tech wasn't there and the homeowner said, will you please do something with this unit? It's never worked right from the time they put it in. But the man that put it in told me he done everything right. So who do you believe? Well, sometimes you got to look at, let's see what the install tells me, and what I've seen on the install, it confirmed the homeowner it never worked right from the word go. So once the measurement of static pressure is completed, take any necessary action steps to make corrections to the ductwork, the components, or airflow settings in order to improve overall system performances and air distribution. Another way to use the manometer beyond the taking the external pressure is to actually test pressure drops, like from a filter or a coil, because if you look at a lot of times, sometimes in those install manuals, it'll tell you what a wet coil static pressure should be and what a dry coil static pressure should be. So the dry coil, like if you look on your heat kit, it'll tell you what the pressure loss is on that particular heat kit. And if you look in your manual, it'll tell you what kind of filter will have a pressure drop, but also the grill you use. Now I've seen people put 4x10 grills in a slot. So when we do the static pressure and you get it completed, you want to look at what the wet coil and the heat kit and the filters and all those things that will have a pressure loss that need to be measured. But in doing so, I've seen installers use a 4x10 supply grill on a 4x10 boot to a 6-inch round, and with the understanding that 6-inch carries 100 CFM, and they just assume because 6-inch carries 100 CFM that the boot and the grill will carry that 100 CFM, and that's not necessarily the case. On some of those 4x10s, they only carry 50 CFM through that 421 or that 681 Hart and Cooley grill. So you need to know what CFM that grill is going to produce, what boot size the CFM is going to produce, what size your flex is going to produce, and what size your ductwork is going to produce, because every one of these restrictions causes static pressure. So let's say you're putting in a house and you need a room that needs 100 CFM, and you put a 6-inch flex into it, and you don't pull the flex tight, and then you have the grill in, and the grill's only going to let 50 CFMs come through it. So then you got to look at, well, now you're undersized already, and you put a lot of stress on that motor and that compressor when you look at the overall scheme of the house. And sometimes you won't see that until about 6 months. We were in a house, and I got called out because the unit was making unreal loud noise. And the installer put it in 6 months ago, and he was very upset and was telling us he wanted a new unit, that this thing was only 6 months old and it was rattling like it was about to come apart. And when I pulled in the driveway and got out of the truck, I knew instantly what was wrong just by listening to the compressor. I could hear it from the backyard. So I knew the unit was under a lot of stress. So we go in the attic, check static pressure, and on the data plate on the unit, it was tested at 0.02. But what real life was actually happening was 1.23. And I asked him, I said, did you set static pressure? Well, he didn't know what static pressure was. He didn't know you had to set static pressure. Never even heard of static pressure. He just knew the unit was loud. Well, we started talking to him, asking questions, and the homeowner just wanted the unit changed out, not the ductwork. And the ductwork was a metal duct, rectangle duct, insulated on the inside. It was laying flat. So it was like 24 inches wide, 8 inches tall. And then when you laid the air handler down horizontal left, well, the way the opening was made, he went straight down into the ductwork. and created his own deadhead because he blocked off half of the airflow coming out of the air handler. And so you get situations like that, and you have to look at that and say, okay, I need at least 4 foot, 6 foot's best to be able to come out of the unit with the size I'm supposed to have, and then transition into what the homeowner had. And I told him, even if you took all the takeoffs off the ductwork, turned the trunk line up on its edge, and then hooked the air handler straight into it, and then reconnected those fittings or the takeoffs, and then pulled your flex, really tight, you'd have stood a better chance than the way he done it. So also look at, when you install things, plan it out, look at it, go path of least resistance, and you're going to have a better luck on your static pressure reading. But like we said, you're going to reduce your cooling efficiency by 50% if you have high static pressure. So take static pressure very serious, and check static pressure on the maintenance calls or on your repairs. If you're putting in a capacitor, doesn't hurt to find out why that compressor was under strain. Was it really dirty cools like everybody thinks the capacitor pops because it's dirty cools and it's hot outside? What if that compressor is under strain? You could go in and test static pressure, see how bad it is, and actually you can get money off your cell calls, service calls, just by showing the homeowner how bad the static pressure is, and then going in and fixing the problem for them, and then you're going to have a happy customer. So understanding what static pressure is, it is king. It needs to be treated as king. And then you see these spider boxes, and I've heard people say, well, I've been doing spider boxes, and I've never had issues with them. Well, you're not there when it happens. It may take 6 months to a year. I've seen some crazy stuff in my time, and I've seen where units, they have hard pipe up in the ceiling, and then they run the units on the floor, and they run flex from that unit up into the hard pipe, and flex is just connecting the unit to the trunk line, and then they put a 14-inch flex on a 3-ton system. And when you took the cover off of the unit, the flex line was under so much pressure it was shaking because it could finally breathe, and that's what caused the attention that I seen. And I was like, holy cow, this isn't good. And yet, when homeowners if homeowners really did their research to find out what install companies actually do the job right, it would limit things down. But we talk about that ASHRAE hard pipe. I'm just going to read these real quick for you. 5-inch ductwork in flex duct carries 50 CFMs, but in hard pipe it's 67 CFMs. 6-inch flex carries 75. Now keep in mind, this is pulled tight. Hard pipe carries 110. 7-inch flex is 110, but in hard pipe it's 160. 8-inch is 160, but in hard pipe it's 230. 10-inch is 300 on flex, 420 on hard pipe. 12-inch is 480 in flex, 660 in hard pipe. 14-inch is 700 in flex, 1,000 in hard pipe. 16-inch is 1,000 in flex, 1,460 in hard pipe. And then the numbers change from there. 18 inches is 1,300 in flex, 2,000 in hard pipe. 20-inch, 1,700 flex, 2,600 in hard pipe. So definitely looking at those things to get the right size, to get the right hard pipe or flex. You've got to pull your flex tight, but you're still only going to carry less CFM. So look at the pricing. If I needed 14-inch flex, or I needed 1,000 CFMs, and I put 14-inch flex in because I'm thinking that's what it is, and then you starve the unit, look at how much you have to go in. Is a box of 16-inch flex cheaper than 14-inch hard pipe? That's stuff you got to look at. Then you got to look at, well, I got to buy wrap, and I got to do all this extra labor. I got to have tape. I got to have mastic. I got to have all these things. And so flex is so labor quick, you save a lot of labor on it, but you're going to have issues if you don't do it right. So those are things that you really need to take into consideration. Adding your numbers together. We're going to be doing classes on how to do that live. We actually have a system that I carry around with me a package unit that's hooked up and ready, and I show them how to take the static pressure of that. But a lot of times too is, like I said, is going by your ductwork, making sure your ductwork is right size and you're delivering enough CFMs for the house. And if you do so, you're going to be a lot happier and a lot more successful. I hope this helped you some. You can always look on our website, tsaedsupply.com, for some more information. Or you can drop by the store and kind of go that route too. But check out the website. If you have any issues or questions, drop us a line. You can connect with me right there on the website. And be looking for more podcasts to come.